Hello, my JHS2 students. Welcome to another week. We are still continuing with ratio and proportion. And today we are looking at application of ratio and proportion to scale drawing. Remember that when we're doing graph work, we normally give you a scale. Do you remember? So we say that with a scale of 2 centimeters to 1 unit, a scale of this and that. Now the thing with scale is that scale can actually give you an object, and that scale they've given you the object they've given you can either be bigger than that object or it can be smaller than the object they've given you. So that's the main use of a scale, and we use ratio and proportion to determine the scale of a given object. Now I have two triangles on the board. What do you notice? That this one is smaller than this triangle, but they are the same type of triangle. But this one is smaller. Now, this is the actual drawing you were given, and now it was reduced to this length. So this is what we call the scale drawing, and this is what we call the actual object. So this is the actual object that you had, and the scale they gave you that you used reduced this drawing to this drawing. Now, when you have these two shapes, you can easily find the scale. So that is what we are looking at today. Now, when you have these two shapes, they ask you that what is the scale drawing, or find the scale drawing. Now, scale drawing has a formula. What is the formula? Any length on the scale all over the corresponding length on the actual object. The word you are supposed to pay attention here is what? Corresponding. Corresponding. Now, the word you are paying attention to here is corresponding. This means that if you are picking this length, it has to be over this length. You get it? So this length here has to be over this, and when you are finding the scale, same as this length here should be over this length here, or this length here should be over this length here. So this length here is corresponding to this length here. Same as this length here is this length here, AB, is corresponding to what? PQ. So they've given you these two shapes. This is the actual shape they gave you, and they used a scale, and that scale gave them this object or this shape, but this time it was reduced. So you are being asked to find what scale they used to reduce this shape to this shape. Now this is the formula you use. Any length on the corresponding drawing. So this is the one they gave us, so we pick this one. Now any length on the scale drawing, this is the scale drawing. So you pick this length, it is 2. So that is what I have here, 2 over the corresponding length on the actual drawing, which is this length. So it's going to be 2 over what? 4. So at the end of the day, this one, 2 goes into itself 1 and goes into 4, what? 2. So my scale, or the scale that they use to reduce this to this, is 1 is to 2. So that is how easy it is. Now you can say that this figure uses 1 centimeter to represent 2 centimeters. That is how you can write your scale. So that is how easy it is. Okay, now let's look here. Now a scale, let's read what's on the board. A scale on a map is an example of ratio, or of a ratio. So you have N here. Okay. A scale on a map is another example of a ratio. It is often expressed in the form 1 is to n, where n is a rational number. So n is a rational number. It is not going to be a fraction. It has to be from 1 to 100 to whatever, but it is not a fraction. So where n is a rational number. Example, we have the scale 1 is to 200,000 means that 1 centimeter on the map represents what? 200 centimeters or 2 kilometers on the ground. So you get it. So you see how the Ghana map is drawn. So what it means that when you measure 1 centimeters on your map, so let's say if I have this map here like this, they are saying that from here to here, if this place is 1 centimeter here, 1 centimeter here on the map, this 1 centimeter on the actual Ghana map is 2 kilometers or 200 centimeters. I hope you understand. But you know, you cannot bring the whole, and you can't draw it on a piece of paper. So for you to be able to draw it, you have to reduce the scale. So they are saying that every 1 centimeter on the map represents what? 200 centimeters on the actual ground. You get it? On the classroom in which you are, you cannot draw this whole big classroom on a piece of paper. You have to reduce the size of the classroom to be able to draw it on a piece of paper. So after drawing my piece of paper, I tell you that every 1 centimeter on my map represents what? 200 centimeters on the actual ground in the classroom. So if from here to here is, let's say from here to here, from here to here is 4 centimeters. I tell you from here to here on my map is 4 centimeters. That means, this means that it is what? 400 centimeters in the classroom or 4 kilometers on the actual ground in the classroom. So I hope you understand this. And also remember that 200 centimeters is also equal to what? 2 kilometers. Okay, so 200,000 centimeters is equal to what? 2 kilometers. Same as what? 100,000 centimeters is equal to what? 1 kilometer. So 100 centimeters is equal to what? 1 kilometer. So if I tell you that 1 centimeter on my map is 200 centimeters on the actual ground, that means if I measure 1 centimeter on my map, on the actual ground is actually what? 100 centimeters. And 100 centimeters is also equal, in kilometers is what? 1 kilometer. So sorry, 100,000. 100,000 centimeters is equal to 1 kilometer. Sorry for my 100,000 and my thousands. Okay, now let's take this question. A map of a large town is drawn to a scale 1 is to 100,000 centimeters. So 1 centimeter is 100,000 centimeters. Now, your first question is, what length on the ground is represented by a line segment 4 centimeters on the map? So now we are going to find the actual length on the ground, which is equal to what? 4 centimeters. Okay. So what they are simply asking you is that what does 4 centimeters on the map represent on the actual ground of the town? So this is how we pick out. So we pick our scale, which is for 1 centimeter is equal to what? 100,000 centimeters. Okay. And what are we finding? 4 centimeters. We are finding 4 centimeters. So they are simply asking you that 4 centimeters on my map, what is it representing actually on the ground? What is the measurement on the actual ground? So definitely we use our if more or less divide. If 1 is equal to 100,000, we are finding more. So it is 4 centimeters all over 1 centimeter times 100,000 centimeters. So CM cancels here. Then we have what? 400,000 centimeters. And what do you remember? 400,000 centimeters is equal to or is the same as what? 4 kilometers. So this simply means that what? 4 centimeters on the map represents 4 kilometers on the actual ground in the town. So this is how simple the question is. Let's read the last question. What length on the map represents 10 kilometers on the ground? what length on the map represent 10 kilometers on the ground? So what is 10 kilometers measurement on the ground? So that is what we are finding here. Our scale still remains 1 centimeter is to what? 100,000 centimeters. And they're asking us to find what? 10 kilometers. What is it going to give us on this map? Now, do you remember that this one can be rewritten as what? 100 centimeters is the same as what? 1 kilometer. So we have 1 cm. 100,000 centimeters is giving us what? 1 kilometer. So you know, there's the same 100,000 centimeters that I have written as what? 1 kilometer. So now I'm finding what? 10 kilometers. What is it going to be on my map? This side is the map. You are finding more, so let's divide. You always remember the ones with the same unit are the ones that we deal with if more or less divided. The one standing on its own is the one coming to multiply. So we are finding more, so let's divide. So we have 10 km divided by less, which is 1 km, times 1 centimeter. So km will cancel km, and what do we have? 10 centimeters. All right, so that means 10 kilometers on the ground, on the actual ground, is equal to 10 centimeters on the map. So that's how simple it is. I hope you've enjoyed today's lesson. And we are going to end here. I'll come your way tomorrow with another subtopic. Have a good day.